In this lecture, we're going to look at the concept of polymorphism, which is a very useful concept in object-oriented development when we have a hierarchical scheme of our classes. So we're going to start off here with a definition of polymorphism. Poly means many, and morph means shapes. So literally it means many shapes. This is when we're dealing with a reference variable. Remember, a reference variable is any variable that's going to be pointing to an object that we've instantiated in our source code. And this is when this type of variable can take on the form of more than one class. Now, the classes that it can take on the form of are, of course, itself, or then any of its children, grandchildren, etc. So any of its subclasses that follow down through the hierarchical scheme there can be assigned to a reference variable of the base type. So we're going to look at a couple different examples here. The first example, we're going to go back to our first assignment here and look at the hierarchical scheme that we had there. And that hierarchical scheme, we had a class dog, and then subclasses of that were the wild dog and the pet dog class. So here we're going to declare a variable of type dog. Now I can create an object of wild dog or pet dog and assign that to a dog variable because these are types of dogs, and through polymorphism I can take on any of my subclasses or their children, etc. going down. So this is a legal assignment here. And then when I call system.out.println and pass in my dog object here, remember here, if I don't have toString, I'm doing a print line, it's going to look for the toString method. So then it goes in here and say, pet dog, oh, did you implement a toString method? It did. So I'm going to call pet dog's toString method. Even though I'm a dog variable, at runtime, when I call this, it says, what type of object am I at right now? It says, oh, I'm a pet dog, so I'm going to call pet dog's toString method. Here's another example here. In this particular instance, I actually have a wild dog variable. Of course, I can assign a wild dog object to that. And here I say system.out.println, Wolfie toString. Well, what am I? I'm a wild dog. Of course, I know I'm a wild dog because that's my data type here. So I'm going to call wild dog's toString method. Now let's say I took my Wolfie object I've already created and assigned that to my dog variable that I've already created. This is a legal assignment because I can assign a subclass, wild dog, to my superclass dog. So in this particular instance, when I say dog.toString, it says, what type am I right now? Well, I'm a wild dog, so I'm going to call the wild dog's toString method. Now here, I cannot assign a dog variable to a Wolfie variable because in this instance, a dog is of type dog, and Wolfie is the type wild dog. So this does not work here in reverse. So this is going to be not legal. You're going to actually get a compilation error. And then also if I have pet dog equals my dog and I say equals new dog, we're going to get a compilation here also because we're trying to assign a parent class to a subclass. Now we can assign subclasses and their children to a parent class, but we can't do this vice versa. We'll actually get a compilation error. Now let's look at another example, which you're going to be working with in your next assignment for this particular unit, where we're going to extend our hierarchical scheme another level. So in the last assignment 2, when we were working with shapes, we created a abstract shape class, and then we derived from that like a circle, a rectangle, a hexagon. So it was just a one-level and deep inheritance scheme. In this next assignment, we're actually going to add another level. So we're going to have a circle whose parent is shape, and then derived from a circle is a spotted circle. So a spotted circle is a shape. Now in this example here, we've declared a variable of type shape called myCircle. We can instantiate a circle. This is legal because the circle class is a subclass of the shape class. Now when I call myCircle.draw, it says what type am I right now? I'm a circle, so it's going to then call the circle's draw method. In the book, when you read on that, you're going to hear this. When it's determining what method it should call, that's known as dynamic or late binding. It determines that at runtime when it knows what type of object it is. In this particular instance, I can say my circle equals new spotted circle. This is legal because a spotted circle is a grandchild of the shape class. So this is legal. Now when I say my circle.draw, once it comes up here, it says, oh, now I'm a spotted circle. So I'm going to go up here and call the spotted circles draw method. Another example, let's say I've declared here just a circle reference variable. I can instantiate this. This is legal because a spotted circle is a circle. And notice you don't have to declare your class to be abstract to be able to assign any of its children to it. So this is a legal assignment. And then when I say a circle.draw, it says what type am I? I'm actually a spotted circle. So it employs dynamic binding. It says we're going to call the spotted circles draw method. Now if I call a circle.move, it still knows that I'm a spotted circle, but one of the benefits of inheritance is that since all shapes move the same way, I didn't have to re-implement the move method in the circle class or the spotted circle class. So in this instance, it's going to go all the way down since we didn't re-implement or overload those methods. It's going to go down and employ the shapes move method here. So this is how we can reduce duplicate code, that if we've got something that all of our children or grandchildren are going to use, we can just implement it once in the base class. We discussed that in last lecture. Here's another example. Spotted circle spots equals new spotted circles. In this instance, spots is of type spotted circles. So the only thing I can assign to it is a spotted circle or then any of its children or grandchildren, etc., if it had such. Now when I say spots.move, remember now through inheritance, it says, oh, I don't have a move method. Does my parent have a move method? No. Does its parent have a move method? Oh, it does. So I'm going to call the shapes move method here. Now just by way of reminder, if I say my circle here, which is actually of type shape, so that's there, and say new shape, this is going to get a compilation error because shape is an abstract class and we cannot instantiate objects that or classes that have been declared abstract. The last example I want you to see here is where some of the real benefit in reducing duplicate code comes in when we use polymorphism in a collection of objects. In the last assignment, we ended up creating 3 different array lists. One for some type shape, and then circle, and maybe a rectangle, and then we eventually made our shape class abstract, so we couldn't instantiate that. So we ended up with 2 array lists, which basically have duplicated code. Now, with our having a parent class, we can assign any of its children or grandchildren objects to a variable of that type. So I've got a little bit different hierarchical scheme here, just enough showing some more children than one grandchildren here, but we're still working with the shape. So I've got a shape, rectangle, circle, and triangle are all subclasses of shape, and then a square is a rectangle. It's just a special type of rectangle. It's a subclass of rectangle. So what I can do in this particular instance is declare an array list of shapes. This here is going to be my common superclass type that I want to say that this array list can hold anything that's actually a shape. In this particular instance, it's abstract, but this didn't necessarily have to be an abstract to be a polymorphic collection of data. Now I go to shapes.add, a new triangle. Well, a triangle is a type of shape, so I'm allowed to actually put a triangle object in this generic collection that I'm creating. Shapes.add new square. Well, a square is a rectangle, which is a shape, so I can add a new square to this. Add another square, add another circle, add another rectangle. So now I don't need separate array lists for a triangle or square or circle. I can just have a single array list and then put any of its children, grandchildren, etc. into this list. So I only need one collection now and not a bunch of different collections. So I can really reduce the amount of duplicated code. Now let's say I've added all these objects to my list. Then if I want to iterate through those, I just say for shape, I set up a for each statement here. When I get current shape.draw, it's going to employ dynamic binding. At this particular point, the first shape's a triangle. It says, oh, I'm a triangle right now, so I'm going to call it the triangles draw method. The next iteration around, it says, oh, I'm a square, so I'm going to call the squares draw method. Next iteration, I'm a square again. You can call its draw method the next iteration of circle. I'm going to call the circle's draw method. So this is how at runtime it determines what type I'm in, or what type I am, and then I will call that type's method and invoke that. So this is what they get this concept of polymorphism, that a variable is going to be either itself or any of its subclasses or their grandchildren, etc. It's a very useful and powerful concept, and you'll experience this a little bit more in the homework assignment this week.